So, hello and welcome everyone. Welcome back again. So, in the previous stream, I was not able to continue the previous stream because I was having some technical issues. So, in this stream, I'm going to explain the problem statement properly from scratch and will be reaching down to the solution. Okay. So, those of you who are in the previous stream, you already know. So, those of you who are attending the stream for the first time, let me share the details with you that today only I'll be conducting the problem of the day at 8 p.m. But now onwards, the problem of the day will be conducted at 6 p.m. next day. Okay, so like if today's problem of the day solution will be delivered tomorrow at 6 p.m. in the evening, right? So let's begin without any kind of delay. So let me share my screen. Okay, I hope my screen is visible. So we are going to solve the question that is our problem of the day, and let's understand. So the name of the question is Night in Geekland. So the problem statement contains, like, it's a long story, but over here we can shorten this problem statement by extracting few of the important points, and the problem statement can break down into three important points which we need to take care of, right? So now let's understand the problem statement. So quickly I'll be I'll be quickly explaining the problem statement. Okay, so let's first of all read down the problem statement. So night is at there is a chessboard given to you, or you can call it as a matrix, and the dimensions are n cross m, and you are given the starting position as start x and start y. And what is the question? The question wants you that the knight will be having some kind of magical power. I will explain the magical power. The statement is written over here, and each and every cell of the board contains some coins associated with it. So what you have to do, you have to find out that what is the minimum number of steps required to collect maximum points. So you have to maximize the number of points, while if there are multiple choice in which you are getting the maximum answer, what you have to do, you have to choose the option in which you will be reaching the maximum points in minimum number of steps. Can I get a quick confirmation in the chat box if the uh, abstract part of the problem statement was clear to everyone? A quick confirmation, yes or no? Okay, thank you for the confirmation. So now let's move and understand the problem statement. I'll be first of all extracting three main points. Okay, so let me first of all explain you that in the question it is mentioned that each cell in the matrix contains some points. I already explained that point. And in the ith step, here the details about that, if you are considering the ith step, what is the count of coins that you can collect. So it is mentioned that in the ith step, the knight can collect all the points from all the cells that can be visited in exactly I steps. So it says that, let's say cell number 1, cell number 2, cell number 3. You can visit all the different cells in ith step. Then the amount of coins that knight will be getting in the ith step is the sum of coins associated with each individual cells. So let me explain. So we'll be taking a smaller example. The example number 2, the value n and m, that denotes the row number and column number. Start x and start y denotes the starting point of the knight. And this is the detail about the entire grid which is given to you, and each and every cell contains a value. Over here you can observe. So let's first of all quickly write down this entire problem. Okay, thank you for the confirmation. So let me share my entire screen. Okay, so I hope it's visible. Yes, it's clearly visible. So I'll be copying down the entire problem of the problem statement. So it was given that n, what was the value of n? So let me just fetch the value. N is equal to 3, m is equal to 3, and the start n x. And the starting position was given to you as 2 comma 1. This is the starting position of the matrix. And now what you have to do, let me copy the details about the grid array. Just a minute. Okay, so the grid contains 768 914 628 628. Till now, do you have any kind of confusion? Plus one in the chat box if everything was clear. I am putting more emphasis on the problem statement because the story given to you in the problem statement is quite lengthy. And if you don't extract the main points, then it will be very confusing while finding the answer. And without understanding the problem statement 100%, you won't be able to fetch the correct algorithm that will give you accepted that will give you an acceptance for every test cases, right? So the first point was that in the ith step, the total coins. What is the total count of coins you can get in the ith step? It is the sum of all the cells that you can reach in the ith step. It is the sum. Let's say there are k number of cells which you can reach in the ith step. So it is the sum of coins associated with that particular cell. Let's say cell I. Okay, so this is like a formal representation of what that statement meant. Okay, and there is one more statement that needs to be taken care of. That statement is that it is given that the knight has some kind of magical powers, right? So what kind of magical powers? Let's first of all read down what is given in the problem statement. Also, the knight has some magical powers that enable him to fetch coins from the future. Okay, so it says that you can fetch the coins from the future. So if I try to shorten this statement, it is trying to say that, let's say, if you are currently standing at the cell number 1, or let's say currently you are currently at step number 1, then by using the magical power, the knight will be capable of fetching all the coins that he can get at step number 3 or 4 or anything, right? So according to the problem statement, it is mentioned if the knight can collect y coins in the xth step, he can fetch all the coins that he will collect in x plus yth step. And it is written down once more in another terms. So I'll be not reading down that again, but I'll explain. So the statement is trying to say that if, let's say, the step number over here, you are given the step number is s, and the coins you can collect in that step is c. Okay, so the knight is saying that the magical power is such, you can use the magical power in such a way that you take the sum of step number and the coins you can get at that particular step, and find that what is the amount of coins you can get at the step number s plus c. So whatever is the amount you are getting, whatever is the count of coin you are getting, by using the magical power, you can get all the number of coins. Let's say over here you are getting capital A as the total count of coins. So at the step number S, you can get in total C plus A amount of coins by using the magical power. Okay. So can I know whether this part was clear or not? The magical part. Was the explanation about the statement of power clear to everyone? A quick plus one in the chat box. Okay, I'll read down the comments, but I want the confirmation, so do mention it in the chat box. And there was the last step. This step indicates how to find the answer. So you have to find out what is the minimum step in which you can get maximum coins. In which you can get maximum coins. Okay. So what this statement is trying to say, that let's say you are able to get a maximum amount of coins by step number 1, or let's say step number 2. There were different possibilities. You can reach the maximum count of coins by step number 1, 2, step number 3, and step number 4. And the inequality between all of them is that the step number 1 is the smallest one. Then you have to print S1 in the output. You'll be able to understand over here. So let's solve this problem test case. And let me mention the indexes 0, 1, 2 and 0, 1 and 2. So now over here, the starting point given to us is 2 comma 0. This is the starting point, 2 comma 1. So if you aren't aware about the movement of a knight, let me explain you quickly that the knight can move in 8 different direction. I think you have already played the game of chess in the, like, whenever you were in the school, or some of you might be playing the chess uh, these days as well, right? So the knight moves in 8 different directions. 8 different directions are possible. These are the 8 different directions. Okay, so the movement of knight is similar to what is there in the chessboard. So the same movement is to be followed in this statement as well. So now from this position, where can you move your knight? So I can move in this direction. I can move in this direction. I can reach this cell. I can reach this cell. So currently, I'll be noting down that what is the count of cell associated with particular step number, right? So I'll be noting down, let's say these are the steps and these are the coins associated with it. So steps and the coins associated. So step number 1, 0, 1 and 2. And the counting of steps according to the question starts from 0. So currently the 0 number step means that it is the initial position. What is the initial position? 2 comma 1. What is the count of coins? I can see 2. So now these two positions which I have marked over here will be considered as step number 1, because you are moving your knight from position this to this, right? So what is the count I can get? I can get 7 plus 8. I can either go to this cell, I can go to this cell as well. But this, both the cells are reachable in one step, right? So the count comes out to be 15 in this case. So this is the value associated with step number 1. So moving on forward. So let's say both these cells were explored, and now let's say from these two cells, where can you reach? From these two cells, where are the, on which cells can you reach? From this cell you can reach in this direction. Let's say you can reach over here. Let me change the color. You can reach over here. From here you can move this direction, and if the knight was standing at this position, you can take your knight at this position, right? So that would be considered as step number 2. So step number 2, the sum is 9 plus 4, that is equal to 13. So value associated with that step number is going to be 13. Okay, so let me erase this part, the arrows. And now let's find out if your current position for step number 2 was 9 and 14. From 9, where can you move your knight? I can move in this direction. From this 9, I can take my knight over here, and from 4, I can take my knight over here. So the value associated with the step number 3 is going to be 6 plus 8, that is equal to 14. So this is 14 for the step number 3. Is it making sense? Are you guys able to understand what the question says, how you need to calculate the value of coins associated with every steps? Is it clear? A quick +1 in the chat box. I want the confirmation in the chat box. And now if this was your last position, then from this position the knight will be capable of moving to this cell. Both the from 6 also you will be able to move to this cell, and from 8 also you will be able to move to this cell, right? So that would be considered as your step number 4, and the value associated with the step number 4, that is count of coins, is equal to 6. Okay, fine. And now I have visited every cell, and now do you think can I move in any different direction apart from this? Let's say the last position was our 0 comma 1. So do you think you can move anywhere from 0 comma 1? Can it be done by Q, or it's very slow? Okay, the solution. Okay, we'll come to the solution part as well. You mentioned the data structure, correct? Okay, you can do that in that manner as well. So from 6, I will not be able to move anywhere else. Now you have got the value associated with every step. That in each step you will be getting this many number of coins in total. So now what you have to do, you have to find out that if you use magical powers at every step, what is the count of coins that you can get. So let's say I'll write down one more value, that is called after using the magic power, after using the magical power at every step. So I have already explained that you have to find out what is the number of coins at S plus C. I will explain. So this is your step. I'm solving it for step number 0. I'm using the magical power. So that would be, I will be finding what is the coin, what is the count of coins associated with 0 plus 2. That is step number and coin number. So that is 0 plus 2, and that gives me 2. So you have to find out what is the count of coins at step number 2. You can get that entire amount of coins in 0th step itself by using the magical power. So at 0th step, in total you will be having 13 plus 2. Already you had 2, right? So 13 plus 2, that is equal to 15. So by using the magical power, you will be having 15 coins at the 0th step itself. Now over here, moving on forward to this one. So let's find out the answer if you use the magical power. So if I use the magical power, first of all, I will be adding the step number and the count of coins. 1 plus 15 is equal to 16. So do you think, is there any step 16? No, I cannot see any step 16. So the value after magical power remains 15 as it is. So moving on forward for this one, for this step, what will be the magical power step? That would be 15. So do you think at the step number 15, is there any step number 15 for this question? No, I cannot see. So the count of coins remain as it is, that is 13. For this one, let's find out. So that would be 3 plus 14. So at the 17th step number, do you see any 17th step number? No, I cannot see. So the count of coins remains as it is. So now 4 plus 6, that would be 10. For the last one, do you see any kind of step number 10 over here for this test case? No. So the count remains as it is. So now this is the array. This is the magical array from which you have to figure out what is going to be your answer. Okay. So let's focus on this magic array and find out what is the maximum number of coins that you can get. So among all these values over here, what is the maximum value of coin? That is 15. Okay, but here you can observe that you can get 15 coins at step number 0 and step number 1. So what is the minimum step? Obviously 0 is the minimum step in which you are getting 15 number of coins. So that means the output for this will be 0. You can observe in the example number 2, the output comes out to be 0. Is it clear? A quick confirmation in the chat box. Was the problem statement clear to everyone? +1 in the chat box, and then we'll be moving towards the solution part. Okay, thank you for the confirmation, Akhil. So just a minute. Okay, I'm back again. So now over here, the problem statement, the question was kind of trickier one, right? The problem statement was kind of tricky, but we simply need to focus on this different scenarios. These 3 points are very important to solve the question, and we have extracted the main concept, main problem statement from the entire story available, right? So what is the final step? While solving this test case number 2, you were able to observe that somehow, if you are able to find this magical array, if you are somehow able to derive the values of this magic array, then you simply need to find out what is the maximum value of this magic array, right? We did that thing only, no? We found that this is the magic array, and we found the maximum number of coins. I came to know 15 is the maximum value, and from this 15, what did we do? We chose the step number which was minimum. We chose the step number which was minimum. So simply iterating over this array and finding the maximum value. And if you get repetitive value or duplicate value, choose the one that requires least amount of steps. That was the entire process. So we need to focus on somehow finding this magical array. So how did you derive this magical array? You derived this magical array with the help of this array. That was steps array and coins array, right? So over here, the what is the meaning of steps of I? That is, what is the meaning of coins associated with ith step? Let's say if this is the ith step, then what is the count of coins? It is the sum of all the coins that you can get by visiting all these cells, right? coins that you can get by visiting all the cells in the ith step. In the ith step, how many cells can you visit? Take the sum of their coins and you will be getting the amount of coins you can get in the ith step. So over here, if you observe carefully, if you draw the entire relation between the steps and count, you will be able to figure out that there would be a recursive tree available, or you can observe it with the help of a tree. Okay, so let me explain. So now over here, so red one is the step number 0. Okay, I'll be noting down the color. So in this step number 0, how many cells were you able to visit? Step number 0, that is the beginning one. So that is 2 comma 1 was the cell number. So from over here, how many cells were you able to visit? I was able to visit this 0 comma 0 and 0 comma 2. 0 comma 0 and 0 comma 2 were you were able to visit. And from 0 comma 0, how many cells were you able to visit? From 0 comma 0, you were able to visit this cell. And from this 0 comma 2, you were able to visit cell number 1 comma 0, right? So now mentioning over here, focus on how I'm creating this entire tree. Okay, from 0 comma 0, you were able to visit 1 comma 2, and from 8 comma from the 0 comma 2, this cell, you were able to visit 1 comma 0. This was the only possibility. Other possibility was already explored, or it was out of the bound of this entire array. So simultaneously, I can mention the steps number as well. So this is step number 0, step number 1, this is step number 2, right? Is this blue color visible clearly? Okay, I think it's pretty much visible. Okay, so from step number 2, where can I go? These are the cells, that is 1 comma 0 and 1 comma 2 are the cells. From this cell, you can visit how many cells? You can visit this cell and this cell which are not visited. So that is 2 comma 0 and 2 comma 2. So from 1 comma 0, you will be able to visit 2 comma 2, and from 1 comma 2, that is this one, you will be able to visit 2 comma 0. And now from these two cells, which cell are you able to visit? You will be only able to visit this cell, that is 0 comma 1. So this will be common for both of them, that is 0 comma 1, and which was not visited. And let me write down the steps count over here, 3, and this is step count 4. And the coins associated is nothing but the value associated with every cell number. Okay, so this can be achieved with the help of BFS algorithm. The main heart of the problem, the main algorithm which will give you the entire solution, is the BFS algorithm. You can traverse this entire matrix in this manner, and over here you will be able to generate this kind of traversal tree with the help of breadth first search, because for every cell you have 8 different direction. You can consider the cell as a node, and the adjacent direction, or the 8 different direction for the night movement, you can consider them as their adjacent nodes. And you will be only visiting those nodes which are inside the boundary of the grid, as well as they are not visited, right? Was it clear? Is this tree clear to you, everyone? Yes or no in the chat box? +1 in the chat box. The +1 in the chat box. Okay, yes or no in the chat box. And then we'll be moving towards understanding how we are going to apply BFS algorithm. So if we are able to generate this kind of traversal, right? Let's say I was using the BFS level order traversal. Okay, to be more precise, you have to use the BFS algorithm in which you are traversing the nodes in level order manner. You have to separate the nodes which are part of your different level. Okay, so now let me just, for like getting the clear idea, let me write the value associated with every cells, so we'll be getting the count as well, right? So 2 comma 1, 2 comma 1, what is the cell value? It is 2. For 0 comma 0, it's 7. For 0 comma 2, it's 8. For 1 comma 2, this is 1. 1 comma 2, it's 4. And for 1 comma 0, it's 9. For 2 comma 0, it's 6. and for 2 comma 2 it's equal to 8, and for 0 comma 1 I'm just writing down this value associated. 0 comma 1 it's 6, right? And the total coins associated, okay, and the coins you can get for every step, it is the sum of both of them. 7 plus 8 15, over here 9 plus 4 13, 6 plus 8 that is 14, and over here only one cell, so 6 will be the value, and over here the coins will be equal to 2. So this is how you have to solve this question. Okay, so now from this we can apply the BFS algorithm. This entire thing is nothing but breadth first search on the grid. And to be more precise, you have to use level order separation while doing the breadth first search algorithm. Let's say you can call this steps, or you can call them as level. It denotes the level number. We know how to use level order traversal. If you are not aware about the level order traversal using breadth first search, I would highly recommend that algorithm. Is very standard and it's very important that you know that BFS algorithm. Okay, so go through that algorithm and you will be able to solve this question. So you can consider them as level. So level 0, the value associated is 2. So what I'll be doing after fetching all these values, I'll be creating an array. After getting all the values each and every level of coins, that is total count of coins associated with every level, I will be creating an array to store these requirements. To store this value, you need something, right? So I'll be creating an array. So you might be wondering what will be the size of the array. If we are creating an array, we need the size, right? But here we are not sure how many levels you will be traversing, how many levels are required. So what you will be doing, you will be creating an array list or a vector in C++, right? We need dynamic sized array if we are not aware about the size of the array. So we'll be using dynamic sized array. And how will you store the value? So we have to store in this manner. Step, and then you will be getting the coins. So in the vector or in the array list, I will be considering the step as my index, and I'll be considering the coins is nothing but the value associated with that particular index. Just mapping the value inside the array, just like the frequency array, right? So I'll be creating a vector or an array list according to your language, and then you will be able to store the value. So for that you won't need this step count. I'll explain how will you do that. So from this, were you able to understand how we are solving this question? How will you reach the entire solution? Was the idea of BFS? How will you apply the BFS clear to everyone? A plus one in the chat box so I can know whether the idea of how to apply BFS or the thought process behind reaching the BFS algorithm, was this clear? A plus one in the chat box. I'll be more than like happy to know that you are able to understand. Okay, thank you, Akhil. Thank you for the confirmation. So this is how I'm going to use BFS algorithm. And Akhil was mentioning that we can use Q, right? Yes, obviously BFS using BFS also uses Q data structure, right? So that is exactly what we need in BFS algorithm. You were right, Akhil, when you mentioned that point. Okay. So now we simply need BFS algorithm. We need to apply BFS. If you don't know how to apply breadth first search or DFS algorithm on a grid, then you need to again solve standard problems that are based on matrix and graph. Okay, so I'll mention one more thing, and then we'll be moving towards the coding implementation. So that thing is, we need the directions, right? If we are talking about graph data structure, then you will be given adjacency list or array list, adjacency list or adjacency matrix. But here you aren't given any kind of adjacency data structure to know what are the adjacency nodes. So we'll focus on the direction of the knight. We know that knight can move in 8 different directions, right? If your knight was standing at this position, he can move in this two direction, this, and this over here, right? If this was your I comma j, and if you draw the entire, let's say, let me draw this and show you. If you are currently standing at this position, then the knight can move in this 8 different directions. Just for the explanation part, because some might not be able to understand it properly. 8 different direction. Which 8 different direction? So let's see. This. These are the 8 different direction, and you simply need to know the coordinates of this direction, like what needs to be added to your row number and what needs to be added or subtracted to your column number. If this was your I comma j, if you want to reach at this position, you simply need to subtract the row number by 2 and subtract the column number by 1. Whatever is the current row and column number, subtract -2 and -1 from column and from row and column number respectively, and you will be getting the coordinate of this cell. Similarly, for this one, if you want to know, you simply need to add one column and you need to subtract the row number. For this one, you simply need to add two columns and you need to subtract one row number. And this way, you will be able to figure out all the coordinates. I'm not writing down all the coordinates right now. And for this one, let's write down, right? So for this one, you need to increase the row number, increase the column number. For this one, what you need to do? For this number, increase the row number by 2 and increase the column number by 1. For this cell, you simply need to increase the column number by 2 while decrease the the row number by 2, column number by 1. And for this one, what you need to do? You simply need to increase the row number by 1 while the column number needs to be decreased by 2. So these are the 8 different directions, and this was remaining. So for this one, column number needs to be decreased by 2 while the row number needs to be decreased by 1. Okay, so these are the final coordinates. Is it clear, this coordinate part? If I have if you aren't aware about this coordinate system, I would highly recommend go through that as well. Okay, so this is how we will be finding out all the adjacent nodes to your current cell I comma j. Okay, and now obviously you need to identify whether the cell number which you are getting, that is I dash and j dash, it should lie in your grid, right? So you'll be using some function to check out whether the value is positive and it is lesser than your row number and column number. So now we can move forward and write down the solution of it. First of all, I will be needing a BFS algorithm. You need the BFS algorithm to fill the value inside the array which you are creating, to store the steps and coins associated with it. And then you will be iterating over this array to fetch the value you can get by using the magic. Okay, so that was it. So we'll be coding this part. First of all, BFS, a normal BFS algorithm. Let's see. Okay, so do you have any kind of doubt? Can I know? Like, is there any kind of doubt from your end? Then please mention it right now. Any doubts? Any doubt in the explanation part? Yes or no? Quickly, quick reply in the chat box. Okay, I see no doubts coming. So let's move forward and solve this question. So first of all, in the queue data structure, you need to store a pair because the cell is denoted with the help of row number and column number. You need to store a pair. So what you can do, you can create an object of pair. In the magic step, we shouldn't mark nodes visited. So while applying BFS, the BFS algorithm itself suggests that you need to mark the cells visited as well, right? So I haven't mentioned it because I thought everyone knows BFS algorithm. So obviously you need to mark the cells visited, which you have already traversed through while applying BFS. In the magical step is to get the count of coins. Okay, so over there won't be any iteration over the entire grid. A simple iteration over the array which you are going to create. Okay, Akhil, was it clear? Okay, so let's start. First of all, what I'll be doing, I'll be creating an array. Let's not create the array. First of all, Let's extract the row number and the column number, and I'm changing the argument as x and y. Okay, so row number will be denoted by n, and the column number will be denoted by m. So now I have the row number and column number. So what I'll be needing a visited array. So visited array can be of Boolean type. I've created a Boolean array that is the size of the array or the grid. I'll be calling it as grid instead of array. Okay. So don't confuse yourself between grid and array. So this is called as grid. So now what do you need for the BFS algorithm? You will be needing a queue data structure. Inside the queue, you need to store a pair. Inside the queue, you need to store a pair. What I'll be doing, I'll be creating an array that is the queue will be capable of storing an entire array. Okay. And this is how you create a queue in Java. So this is, you will be hello. Okay. So you have created a queue. Now the starting position is given to you, that is x comma y. So first of all, wherever you are currently standing, you need to mark that position as visited. But before that, in order to store the answer, what else do you need? In order to store the answer, you need an array. And let's call that array as coins array. And what will be the size of that array? I don't know the size, so I'll be creating an array list instead. You can create a dynamic size array according to your language. And I'll be calling it as coins to store the answer, at the value of coins associated with that particular step. So now I have the coins array, I have the queue data structure, and now let's apply the BFS. So we know that the starting position is x comma y. So obviously x comma y needs to be marked as visited, and it is the initial starting node. So I'll be inserting it inside my queue data structure. So visited of x comma y will be true. And in Java, you don't need to mark the entire grid true or false, because it will be already initialized by the default value false for Boolean. And now let's insert it inside the queue data structure. So you need to insert the array. So what I'll be doing, you will be creating an array, or let's say creating a pair object will be more uh, meaningful rather than using this way. So what do you think? Do you want me to create the queue array or what? Okay, so let's create a pair. What I'm doing, I'm creating a pair class, and that pair class will be capable of containing row number and column number. There are only two values, and this is the constructor, and the values will be associated with the help of this constructor, right? So let's change the queue will be capable of storing an object of pair class. In C++, you already have pair, right? Over here, you don't have the functionality, or let's say the benefit of pair in Java. And now the insertion needs to be done. So the initial cell needs to be inserted. X comma y will be inserted, and it is marked as visited. And one more thing. Okay, so let's start applying the BFS algorithm. I'll explain while completing the algorithm as well. So while the queue is not empty, this is the general algorithmic step. I'm not explaining the entire BFS algorithm. I hope you already know. So now what I'll be doing, I'll be moving level wise. So first of all, I'll be extracting the size of the queue. Whatever is the size, that denotes the total number of nodes at that particular step or level. And I'll be iterating over that many elements in the queue only. So while the size is not equal to 0, I'll keep on extracting and inserting all the neighboring nodes for that particular cell. The code is going to be little bit lengthier, so please pay proper attention, because you'll be, if you are missing some of the thing, then you will be losing much of the information. Okay, so now after getting the size, I'll be one by one extracting the elements from the queue data structure. So let's extract the element, and let's call it as current. So queue.remove will fetch me the element which was inserted first. And now what I need to do, For this current element, what you have to do, you are currently standing at this, let's say, step number I or level number ith level. You need to find out what is the total number of coins at the ith level. So whenever you remove a node from the queue, make sure you keep the count of coins for that level. So for that, what you can use an array, or let's say a temporary variable, or what we'll be calling, let's call it as temporary only. So this temporary variable will be storing the count of coins for that particular level. So first of all, let's find out what is the count of coins. So I'll be going to the, inside our grid, I'll be going to the coordinates mentioned by current dot x, that is the row number. Over here, row r is the element for row number, and current dot column. So this value will be added. Now you need to iterate over all the adjacent nodes. So for that, as I mentioned over here while explaining, that you need to add or subtract something to row number and column number. So what I'll be doing, I'll be creating a direction array. So integer direction is equal to, and now let's fill the value inside this direction array. So I'll quickly fill out the values inside the direction array. I have already written down the coordinates which are required, and these are the coordinates which you will be going through. So now I simply need to iterate over the direction array. And how many values will be there at max? At max 8 number of addition nodes are possible. So let's find out the new row number and new column number. So new row number will be current row plus whatever value is present at the ith and the zeroth cell number inside your grid. And the new column number nc will be current cell column number plus grid of I and 1. This is the addition of the value for the column number. And now if you have got the new row number and column number, that is your neighbor, you need to check if this is a valid one or not. It shouldn't be out of your bound. So we'll be using a function, we'll be creating a function that denotes, it will be returning true or false if your new row and new column number is a valid one. So are you guys able to understand or not? Till now, was it clear or not? A quick confirmation in the chat box. The code is going to be a little bit lengthier. A quick +1 in the chat box if you all are able to understand it in a better way. Okay, thank you, Akhil, for the confirmation. So is valid will return if it is a valid one. And one more thing, we need to check whether the cell is visited or not. Do not forget this point. If you forget this point, there would be an infinite loop and you won't be able to figure it out. Okay, so if that cell is not visited, new cell is not visited, and only then you will be visiting it. So if this is valid is true and it is not visited, then only then visit that cell. So visiting that cell means inserting it inside your queue data structure and marking it as visited. So first of all, let's mark it as visited. So whenever you are inserting something, whenever you are inserting inside your queue any of the node, immediately mark it as visited. Okay, that is the most safest way to apply BFS. And now what you need to do, make an entry inside your queue. So I'll be adding it as a new object of pair class. So that would be NR and NC, new cell number and new column number. So after doing this thing over here, we have added the value of our coin associated, right, inside the temp. Now all the adjacent nodes will be visited by this loop for our current node, and this loop will iterate over all the nodes for that particular level. So if that current level is completed, what else do you need to do? You need to make an entry inside your coins list. Simply add the value of temp inside the coins list. Over here, you don't need the index value because your BFS algorithm is going level by level. First level 0, level 1, level 2, and so on. And in the same way, you are making an entry inside your list for the level 0, and an element will be pushed at the back end. For level 1, an element will be pushed. So obviously their index will be assigned in the same manner as the level number. Okay. And now here is your entire coins array ready. A simple BFS was required. I applied the entire BFS. And now I need to find the values which I'll be getting by using the magical powers. Okay. So now here comes the easiest part of the entire solution. So finding the answer by using the magic. It sounds so like kind of okay. Finding the answer by using the magic. Wow. So now what we need to do? We need to find out that after I use the magic. For using the magic, you know that if for the step number S you have C number of coins, and by using the magic you can catch all the coins you can get at S plus C step. Okay, whatever is the amount of coins you can get it at the step number S itself. Now in order to store the answer, I'll be using two different variables. So one will be denoting the index number or the step count, and let's say it is called as step, and it will be initialized as -1. And another value is the coins associated with that step, because you will be needing to find the maximum coins. The last statement tells you that you have to encounter, you have to take care of two things: minimum number of steps and maximum points. So I'll be needing two variables, and I'll be calling it as, let's say, Cn. I'm calling it as C instead. And now I'll be iterating over the entire array, which is called coins. I'll be iterating from the backend side, because I'll not be using two different separate loop for finding the magical array and for fetching the answer. I'll be simply doing that both the task in the single loop. So I'll be iterating in the backwards manner. You'll be able to understand, and let me call it as S. S is equal to last index. Last index is size -1, and S should be greater than or equal to 0 and decreasing its value. So we'll get the value of coins at that index S for the step number S. What is the coins? So let's say you will be getting, and what, let me change the name of this variable. Let me call it as step coin. Okay, and over here I'll be using the name C. So coins dot get S. Whatever is the amount of coin at the S step number S, I'll be fetching it in a variable S. Now what you need to do, first of all, you need to check whether the step S plus C is out of bound or not. Okay, if S plus C is lesser than or equal to your total number of steps, is lesser than or equal to your total number of steps, or it is lesser than your size of the coins array. Size of the coins array denotes the maximum amount of steps you can achieve on this grid with the help of knight. Okay, if S plus C is lesser than your total number of steps, then what you will be doing? You will be fetching the value. You will be fetching the value at that step. Okay, so let's fetch the value. What is the value associated? So that is get the value at the step number S plus C. So this will be fetching the value of coins I can get at S plus C. And I need to update it inside my, let's say, what do we say, this array list. If you want to update the value, so the updated value will be the coins associated for the step number S plus C and the coins which you are currently having. So this is the new value for the step number S. This is the new value. Is this part clear? Coins S plus C plus C. So the first value, it denotes the value which you are currently having for the current step. And this is the coins you can get by using the magic, by going to step number S plus C. A quick +1 in the chat box for this statement. A quick +1 in the chat box. Now I will be updating. So there is a method called as set method in Java for this. And the index remains as it is. S denotes the index. So new value has been updated. Now here comes the logic for updating our answer. So answer needs to be maximum number of coins, and if you have many steps that can lead you maximum points, choose the minimum step. Okay, so what you will be doing, if your step coin, that is the amount of coin you can get as an answer, if that value is lesser than the coins you can get at current step is step number S, then what you need to do, you need to update your step, that is the answer. जो भी हम आंसर में रखने वाले वैल्यू उसको अपडेट करेंगे, that value is stored inside your variable step. So I'll be updating it, and I'll be simultaneously updating the value of step coin is equal to coins dot get s. Now, in order to handle this minimum part, no, find the minimum number of steps over here. A single inequality that is lesser than won't be sufficient, because as I mentioned over here, while solving the test case number 2, you can observe you can get 15 for step number 1 and for step number 0 as well, but you have to choose 0 as your output because that is the minimum step. So you need inequality lesser than or equal to. Okay, and then the logic is complete. You simply need to return the value of the variable step. Okay, so now let's find out if we have any kind of compilation error. I guess we'll be having few of them. Okay, very silly mistake, that is this one. And now let's try to compile and run again. Okay, array dot length cannot find symbol 60. Okay, this is not array, this is a grid instead. Okay, we already changed the name of the input array as grid. Okay, so this were to a new boolean cannot be, what is the error, boolean cannot be converted. Okay, so here it's a 2D error, so I just forgot one more square bracket. Cannot find symbol length. Okay, so where 60th. Okay, it's not a method, it's a variable in Java. Sorry for this many compilation error, because if I'm coding it instantaneously and while explaining it can take place. Okay, so is valid function implementation was remaining, so let's implement this part. So I'll be keeping it return type as boolean, and row number, column number, and total number of rows and total number of columns. So the row R value should be greater than or equal to 0, and the new column value should be greater than or equal to 0. Row should be lesser than total number of rows, and the column should be lesser than total number of columns. Right? So now there won't be any compilation error. Let's see. For 89. Okay, so let's see 89, 89. 89 and mean 33. Okay, so what is this error 89? Okay, visited of NRNC if it is valid, and not visited NRNC, and current row and current column, and this is it, and NRNC NM. Okay, just a minute. Let's see what mistake have we done over here. Array index out of bound, exception index 3 out of bound for length 3, and 89. It's not the error over here, somewhere else. Direction array, total number of rows, columns, visited, boolean nnm, q. Okay, x and y is the starting position, added inside the queue, mark it as visited, the coins array list, and here is your while the queue is not empty, you will keep on doing it. a temporary variable, the size variable, while the size is greater than or equal to 0, and you will be removing it, and temp plus is equal to grid of R and C, and current row and current column. Total number of rows is 8, and column 0, column 1. There shouldn't be any, this is not the error. A visited of NRNC. I think the compiler is showing the wrong error, like a different error. The line number is not clear over here. Index 3, where did I use index number 3? 0, 1, 2, 3, 4, 5, 6, 7, and 8. Have I used I as a variable? Exploring all the neighbors and NRNC, current row, current column. So let's not focus on debugging it right now. But this is the entire algorithm. We might have made a smaller mistake like accessing anything extra. This is the entire algorithm where I'm not spending much time on finding the compiler this error over here. Visited q linked list. Okay, coins array. Visited of x and y is true, and q is this one. While the queue is not empty and is a time. Okay, and over here, do we have any kind of error? Okay, if s plus c is lesser than your coin size, then set the value for s as this one. Visited is true, q added. Let's copy this entire thing, and let's get the idea over here at IDE1. We will debug it quickly. I know the solution. Can't we copy this driver code? What? Okay, so I think there won't be any way to copy this entire thing. For now, let's not focus on the debugging part. Let me share the other code as well. I don't want to increase the time of this session. Okay, so just a minute. Okay, so let's see. Okay, so this is the same thing what we have done over here, the same algorithm, and let's compile and run. Okay, so the same thing which we were doing, everything is same, and one initialization. Every time, make sure that you whenever you are crossing a level, moving from level 0 or moving from level I to level I plus 1, make sure to change the value of your coins or temporary variable to be equal to 0. Okay, here the name of the variable might be different because this was a previous code. I'll be sharing the link of this code as well in the chat box. So let me quickly copy this code and share it in the chat box. Till now, like, was there any doubt in the algorithmic part, in the problem understanding, or anything? Can I get a confirmation regarding that? Do you have any kind of doubt related to this problem statement implementation part? You want to ask anything extra related to coding, anything? I'll be waiting for a few minutes, and then I'll be ending the session here only. So any doubt? I cannot see any kind of doubts coming from your end. So we'll be ending the session here only. Do try to code this on your own. You will be getting a better understanding. As I mentioned that you can apply BFS algorithm in this way. So do that with the test case number one. The example number one was quite lengthy, so I did not choose example number one. Instead, I chose example number two. Try to do it with example number one. You'll be getting a broad understanding, a more clarity on how you need to approach this kind of questions. So that was it for today's session. Let's like meet in the upcoming sessions, or yeah. So that was it for today's session, and it was great interacting with everyone. Thank you for joining. Thank you.